Hi everyone. What good is math if we can't apply it to the real world, am I right? So what we're going to be doing today is we're going to be using our trig functions of sine, cosine, tangent and seeing how we can incorporate them into some word problems that you might encounter in the real world. To start off with that, we're going to start off by defining angles of elevation and angles of depression. So I have a picture here. The angle of elevation is the angle between what's called the line of sight and the horizontal when an observer looks upward. So here is the angle of elevation. It's made by a horizontal line and by the line of sight when someone looks up. Okay? So that is what the angle of elevation is. The angle of depression is very similar. They're very closely related. This one is also the angle between the line of sight. It's also made with a horizontal when the observer looks, this time it's when they look downward. So this angle right here is the angle of depression. Okay? So big thing here, you got to remember that these angles are made with the horizontal line. Okay? And so horizontal lines are always parallel to each other. So these two horizontal lines are parallel. So actually the angle of elevation and the angle of depression are alternate interior angles. So they're always going to be congruent. So sometimes I might ask for an angle of elevation, but it might be easier to solve for the angle of depression. It's okay to do that because those two angles are congruent. So what you need to really remember here is if I have a point right here and I have a point right here, I could always combine these two using right triangles, or I could always connect these two rather. So right there. So what's my angle of elevation? Here's my 90, so my angle of elevation is always made with the horizontal line. So there it is. If I wanted to use this line and this line, I could have done that, and now my angle of elevation or angle of depression would be up here. It's always made with the horizontal line. All right. Knowing that, let's talk about some word problems that we could solve using trig. So it says a salvage ship uses sonar to determine that the angle of depression to the wreck on the floor is 13.25 degrees. The depth chart shows that the ocean floor is 40 meters below the surface. How far must the diver lowered from the salvage ship walk along the ocean floor to reach the wreck? So I kind of already have a picture for you. Here the diver is lowered, and our directions here is how far must he walk this way, and there's the salvage, or there's the ship that he wants to salvage. So we want to find this distance right here. It's called x. So just because of the way the picture is drawn, I'm going to say this distance is x because this distance is the same as this one on the ocean floor, isn't it? So we could find either distance and both of them would be just fine. It would just be easier, the way the picture is drawn, to find this distance x. Okay? So if we want to find that, we're going to basically ask ourselves the question, what trig function do we use? If 13.25 is the angle of depression, that means 40 is our opposite side and x is our adjacent side. So the trig function that uses opposite and adjacent is the tangent. So the tangent of 13.25 degrees, that equals the opposite side, which is 40, divided by the adjacent side, which is x. Now we're going to apply what we learned yesterday, or 2 days ago, whatever day that was. We'll bring this up here, bring this down here. So x equals 40 divided by the tangent of 13.25. When you put that in your calculator, you get 169.87 meters. 169.87 meters. This diver has to walk or swim this far, 169.87 meters, to get to the wreck. And I'm thinking to myself, boy, that's over a football field and a half. Can you drop me any closer to the wreck, please? I don't want to swim that far. Anyway, that's what we get for this one. Take a look at the next one. Find the angle of elevation of the sun when a 7.6 meter flagpole casts an 18.2 meter shadow. So, as you guys know, when the sun hits something, right, it casts a shadow. And so the shadow is 18.2 meters. So I'm just going to quickly, roughly sketch a shadow of my flag. There's my shadow. How does it look? Looks pretty good, right? Okay. And so if I connect this vertical line and the horizontal line with a hypotenuse right there, okay, this angle right here would be 90. It says that the 7.6 meter flagpole casts an 18.2 meter shadow. 18.2. And our instructions is find the angle of elevation. So one angle is 90. The other two angles are this one and this one. Which one is the angle of elevation? Remember, the angle of elevation and the angle of depression is always made with a horizontal line. So this angle is made with a vertical line and the hypotenuse. And this angle is made with a horizontal line and the hypotenuse. So this is going to be the angle that we want to find. That's the angle of elevation. We'll call that x. It's always made with a horizontal line. So what trig function are we going to use this time? Opposite is 7.6. Adjacent to that angle is 18.2. So once again, the tangent function is going to be our trig function. So the tangent of x degrees equals 7.6 over 18.2. And then whenever we want to solve for an angle, we always use the inverse function. So the inverse tangent of 7.6 over 18.2. And the inverse tangent of 7.6 divided by 18.2 is 22.66 degrees. X equals 22.66 degrees. All right. Hold on to your seats. This last one is a doozy. Let's see if we can understand this one. Olivia is in a lighthouse on a cliff. What a beautiful view, I'm sure. The distance from her to the beach is 145 feet. So she's up here in this lighthouse. Hi, Olivia. And this distance right here to where she is 145 feet. 145. She observes two sailboats due east of the lighthouse, and the angles of depression to the two sailboats are 33 degrees and 57 degrees. Find the distance between the two boats. So from where Olivia is, she spots this boat. So I'm going to make that with a horizontal line. And she also spots this boat. Right? And so I'm also going to draw this horizontal line. All right. So our instructions here is find the distance between these two boats. So what I'm going to do is I'm just going to draw a line from here to here, and I'm going to call that x. That's what we want to find. It's the distance between the two boats. Let me give a quick example about the strategy that I'm going to use to solve for this one. Okay? Here I have a ruler. Okay? And I'm going to have my three kids be my example. Here's Matthew. And here is Joanna. And here is Jeremiah. Jeremiah, Joanna. All right. So if I want the distance between Joanna at 7 centimeters and Jeremiah at 11 centimeters, of course it's 4, right? The distance from Joanna to Jeremiah is 4. But what I could do is I could say if the distance from Matthew to Joanna is 7 and the distance from Matthew to Jeremiah is 11, I could take the 11 and subtract the 7 and get the distance, and that's 4. So that's basically what we're going to do here, class, with these two boats. I'm going to take this distance, I'll call it y, and then I'm going to take this distance, and I'm going to call it x. Sorry, I already have x. I'll call that z. And then I'm going to take y minus z, and I'll get the answer that I want, the distance between the two boats, which we'll call x. Okay? So I'm finding the distance from the lighthouse to the farther boat, finding the distance from the lighthouse to the closer boat, subtract those two distances, and I'll get the ones in between. All right, let's see what we come up with. So it says that my angles of elevation or of depression are 33 and 57. So the angles are always made with a horizontal line. So this angle and this angle are my two angles. One is 33 and one is 57. The more acute angle is going to be 33, and the slightly larger angle, still acute, is going to be 57. So if I want this distance, right, that's my z. 145 is opposite, z is adjacent, so I'm going to use the tangent. The tangent uses opposite over adjacent. So the tangent of 57 degrees equals opposite 145 over the adjacent side, which we'll call z. I'm going to move this down here. Z, you're going to move up top. And z, that distance, is 145 divided by the tangent of 57. When you put that into your calculator, you get z to be 94.16. 94.16 feet. All right, this is good news. From where the lighthouse is to where that first boat is, it's 94 feet. The second boat, this is the distance y, okay? That's also the adjacent side, where 145 is the opposite side of this angle of 33 degrees. So the tangent of 33 equals opposite 145 over adjacent, which is y. So again, I'm going to change around my extremes. And so y equals 145. Divide that by the tangent of 33. I put that in my calculator, and that distance should be farther than 94. When I put that in my calculator, I get 223.28. 223.28 feet. So class, what is the distance between the two boats? This distance right here, x, equals the difference between those two distances of the boats. It's 223.28. Subtract the 94.16 feet. Those two boats are 129.12 feet away from each other. 129.12 feet. So those are some instances where you could use trig in the real world, especially dealing with angles of elevation and angles of depression. Let me know if you have questions when you get to class tomorrow.